This is day 15 of our Leetcode daily question series, and today's question is magnetic force between two balls. So this is a quite similar question to yesterday's question where we were applying binary search to a search range, to answer range. And in this question we have to apply binary search, as we have to check for every answer. And now what the question says is, we have Rick discovered a special form is Rick has n some empty baskets. So Rick has some empty baskets and the ith basket is at position I. So we are given with a array in which the ith basket is position I, as in this example 1 2 3 4 5 7 are the given 1 2 3 4 7 are the given positions of some baskets. So the baskets are the position 1 2 3 4 5 and 7 as placed here and showed here. And Morty has m balls and needs to distribute, so we have to distribute m balls in these baskets in such a way such that the minimum magnetic force between any two balls is maximum. So we have to place the balls at farthest distance so that the minimum magnetic force between any two balls is maximum. Magnetic force will be the modulus of this minus this. Okay, so magnetic, as here written, magnetic force between any two different balls at position x and y is modulus of x minus y. Okay, so given the integer array position and integer m, so these array and integer m is given. Integer m is the number of balls, and now we have to place the ball in such a way so that this force is maximum. So we have to place balls farthest to another balls. And let's see this example. In example, position are given as 1 2 3 4 7. It is not mandatory that it will be sorted, we have to sort, of course. And m equals to 3 here, so we have to place 3 balls. Now we can place 3 balls in such a way, like one here, here and here. So maximum force will be between two balls 4 minus 1 and 7 minus 4, which will be 3. So we have to return the 3 in our answer. And now let's understand the code more thoroughly. Let's understand the problem more thoroughly. Let's take our own example in which position is given as 17432 and m is given as 3. Now as positions are given as 17432, so these will be the position of the baskets on a number line 1 2 3 4 5 6 7, 1 2 3 4 and 7. Now we have to place 3 baskets in such a way that every basket is farthest to another. And how we can do is, we can place one here, one here and one here. So if we place 3 balls in such a way, the minimum difference between the max difference between any two balls will be, here it will be 4 minus 1 and here it will be 7 minus 4. So maximum difference will be maximum force, which equals to 3, and we have to return this maximum force in our answer. So now let's see the approach of doing this question. And in this question, for any greater value for maximum force, we will not get our solution, and as we will not be able to place 3 balls for maximum force 4, we can place only 2 balls here and here, and we don't need to find any smaller value, as we have to return the maximum force. So let's see how we will approach this question. So in this question, we know that our answer will lie between the maximum value of this array and the minimum value 1. Minimum value of not this array, minimum value will always be 1 as given in constraints, and maximum value will be the maximum value in this question, because we can place the last ball at the maximum value only. And let's see how we will do this question. So firstly, we will just sort this array such that it will look like this, and we have to place balls by sorting it. It will make it easy. And as we sort the array, sort position array, it will look like 1 2 3 4 7. And now after sorting the position array, we know that this is the maximum element, so our search space will be search space equals to 1 to 7. And now in this search space, as it is a sorted search space, it is always in a increasing order, as all the values are different given in the question, all the values are distinct in this array. And now our search space is 1 2 3 4 5 6 7. This is our search space. So we will apply binary search in this search space. So in the starting, our starting pointer and ending pointer will be at the starting and ending position for the binary search. And at any point, if we get our solution, if we place 3 balls with any force, then we will check for maximum force only. So we will move our S pointer to middle plus 1, and if we can't find the answer, so we have to check for minimum forces, so we will move our end pointer to mid minus 1. So for this example, what we will do is firstly we will check for the mid. So what will be the mid? Mid which equals to, at this point, 1 plus 7 by 2, which equals to 4. So this will be mid. And now we will check that if we can place the balls in such a way that maximum force will be 4, and we can place 3 balls which is m equals to 3 given or not. So in this solution we will find that we can't place 4 balls in any way. As I explained, we can't place 3 balls. We can place only 2 balls here and here to get the maximum value of force as mid. So we will just reduce our end pointer to the value mid minus 1, because if we can't get answer here, so we will also not get answer after any value of there. So we will get our answer in this range only. So we will move our pointer and equals to mid minus 1. So n will be shifted to here after first iteration of the binary search, and after that we will again find the middle value. So middle value will be s plus e by 2, which is equals to 1 plus 3 by 2, and which equals to 2 in this case. So now this is the middle value, and we will check our answer for this middle value. Does this answer satisfies the question or not? So we will see that we can place a ball here, here and here, or here, here and here, and any condition this solution satisfies the answer. So we can use this solution. So we will just store this solution, and what we will do is we will shift our starting pointer to mid plus 1. As we know, if this is our solution, now we have to find only greater solutions. So we will shift our starting pointer to the right side of the mid. So after this, s will be shifted to here. Now s is here, e is also here. Again we will find mid, as s and d both are equal, so mid will be 3 plus 3 by 2 equals to 3. And now we will again check whether this satisfies our answer or not. And as we discussed, the 3 will be satisfying our answer as 1, as we can place balls here, here and here, and difference is 4 minus 1 3, 7 minus 4 3, is always greater than or equals to 3. So this satisfies our answer. So what we will do, we will store, and again we have to check only on the right side of this value. So we will shift our s equals to mid plus 1, and at this point s will be shifted here, so s will be greater than e, so loop will terminate, and we will get our final answer, which will be stored in the answer. Store in answer. So 3 will be our desired solution. Now let's see how we will check that it is a possible solution or not. So what we will do to check if it is a possible solution, if mid is a possible solution or not. Now we know, as in the given sorted array, these are the positions that where we can place balls. We have to place balls here, here and here in the increasing order only. So for every solution we can place the first ball here. Okay, first ball can always be here. So we will take a counter to count the number of balls that we placed with this solution, and initially the counter will be 1, because we can place one ball always here at the starting position, and the value of the starting position we will mark. Value will be the array name is position, so the starting index of position. So this will be our starting point. Value will be 1 here, and count will be 1 again. Let's say we are checking for mid equals to 4. Let's say we are checking for the mid equals to 4, which we got on our first iteration. So now mid equals to 4. So as we stored the last value, so now we have to check for only that value which when subtracted with this value is greater than or equals to the mid. So now what we can do, we will iterate over here, and 2 minus 1 is 1, which is not greater than or equals to mid, so we will iterate again further. 3 minus 1 is greater than or equals to mid, no. Again we will iterate further. 4 minus 1 is 3, which is now also smaller than mid, and now we will go to here. And now 7 minus 1 is greater than or equals to mid. So we know that we placed the first ball here, and now we can place our second ball only here. So in this case, the counter will be updated here finally when we place another ball. So count will be 1 plus 1 equals to 2. But in the given question, m was 3, so this is not a desired solution. That's why in this case we shifted our end pointer to mid minus 1. Let's say we are checking for the mid equals to 3. What will happen in that case? The initial value at the starting will be same, the count will be same. So count equals to 1, value equals to position of 0, so this is 1 also. And now we will check now we will iterate from left to right, and we will check whether we can place a ball anywhere or not. So after iterating in this array, we will go to this value 2, and we will check that 2 minus the previous value that we had where we placed a ball. So 2 minus 1 is greater than equals to 3, no. So we will again iterate, and at this point we find that we can place another ball, because 4 minus 1 is greater than or equals to 3, so the maximum force is satisfied, and we will place another ball here, and we will update our counter. It will be 2, and we will also update our value, as we have to check for the next value, and we will check the next value with the current value. So value will be great as 4, and now we will again iterate here, and as we get 7, we will check the value as 7 minus the previous value. So 7 minus previous value, 7 minus 4 equals to 3, and which is also greater than or equals to 3. So again the counter will be updated, this value will also be updated, and as the loop terminates here and count equals to 3, at any point if we found count equals to 3, we will just simply break the loop, as we got our desired solution. So if count w equals to n at any point, we will break the loop simply. So this will be our whole approach. Let's code for the same. Let's write the code. Let's first write some variables we will use. So integer I for iteration, maxi equals to 0, and the maxi will be used to find the maximum value here. That will be the last index after sorting the array. And what other values are, we will just take the size of the array, which is n equals to position dot size, and finally we will store answer. Let's mark it -1, whether it doesn't matter, because we will get a solution which is written in constraints. There always be a solution in this question. So what we were doing is, we were first sorting this array. So we will just simply sort this array first. Let's write the function for sort the position array, position dot begin and position dot end. After this, we have to find the maximum value, and the maximum value will be at the last index as we sorted the array. So maxi will be position dot back. Let's use the back function to the last index. The back function will give the last index of the value at the last index of the array. And now we will run the binary search. So for the binary search, let's declare variable. So s will be 1, as we discussed. S will always be 1, no matter what is the minimum value of the position. For the search range, s will be 1, and n will be the maximum value. So e equals to maxi, and we will initialize mid also. Now let's apply the binary search while s is less than equals to e. What we will do is, first we will find the value of mid. So mid equals to s plus e minus s by 2. This thing we do so that we do not fall in the case of the integer overflow by adding the both integer s and e. So we do this simple trick, and now we will check if it is a possible solution, if mid is a possible solution or not. So we'll make a function later named is possible, and what parameters we will pass is mid for checking m, size of array, and our sorted array position. Okay, and if it is a possible solution, what we will do is we will mark our answer again, update the value of answer, and we will shift s equals to mid plus 1. As we got our answer, as in this case we got 2 as our answer, we have to find the maximum answer. So we shifted s equals to s here, so s equals to mid plus 1. And in the else case we doesn't got any answer, so we have to shift e to here. We have to search in the space which is before that space, because if 4 is not answer, any of this value will always not be answer. So we will search in this space, and now so for the else case, e will be shifted to mid minus 1. Okay, and after this we will simply return our answer. So after the whole while loop execution, we will return our answer. Okay. Let's close the function here, and let's write the function of the is possible, that how we will check if a value is possible, if a mid is possible solution or not. So as I explained, we'll use a boolean function is possible. What parameters we passed are int mid, int m, and this vector int and position. Okay, so now let's write the function. So let's use some variables. Let's declare some variables. Int I, j, count equals to 1. We sometimes don't use j, but I declare because it is a habit, so I not have to declare it later. And now what will be value? As we discussed, initially value will be the first value and counter will be initially 1. So value equals to position 0 and counter is 1 simply. And now as I discussed in this, how we will check, we will simply run a loop from the second index. So for I equals to 1, second block, sorry, I less than n, I plus plus. And now if, as we discussed, if the difference of these two is greater than or equals to mid, so we will update our counter and we will update our value. So if position of I minus value is greater than or equals to mid, and we don't have to worry about taking modulus because this value will always be greater as it is in the right side of the array. And if this condition satisfies, what we will do, we will increment our counter and value will also be updated as position of I. As we discussed, as we got here, we updated it as value and we also update our counter. And now if the if condition doesn't satisfy, we don't have to write any else condition right here. And at any point, if count reaches the value m, like here when the count reaches 3, so we have to return true. Saying this is our possible solution. Let's close the for loop here, and if we don't find any, and if we can't find count equals to n, as count will be less than m, so we have to return false after execution of the whole loop. Return false. Let's close the function here. So this is our desired code for this question. Let's submit our code. So our code is accepted. Thank you for watching.